The most simplest, easiest, and most efficient way to understand space-time curvature is by looking at geometry. So let's take a simple geometrical example. There is an orange dot that is moving horizontally towards the right. There is a frame with black borders. The frame is stationary, and there is a marker in the middle which shown by dotted lines to tell you where the middle of the frame is. So nothing special happens. The orange dot moves right in a straight line. Uh, Now let's look at a different case. Now the only difference is that frame would move up. The orange dot moves at the same speed in the same path. If you look at from the frame's point of view, you would have seen that the orange dot entered on the left top and left at the bottom mid of the frame uh, by the time the frame had moved up. The path of the orange dot is shown by the orange curve that is showing a trajectory moving down. Now, when we say from the reference of the frame, we mean that if the observer or if there is a person who is traveling, with the frame, then it will appear to that human or the observer that the orange dot had moved in that trajectory. When we see from the moving frame's reference, we see that the distance that the ball has traveled is more than the distance when the frame was just stationary. Where, as you see that when frame is stationary, the distance traveled is shown by the base of a triangle, and when the frame was moving and we took the frame's reference, the distance traveled was equal to the hypotenuse, and hypotenuse is more than the base. So what it means is that the same orange dot with the same speed and it took same time, but it traveled more distance in the moving frame reference. Now if the velocity of the orange dot is same and it is traveling more distance, then the time also has to be higher to keep the velocity same. And that is what happens, when we say that moving objects have a time that's moves slowly, which means there is a time dilation that is happening. Thank you for watching. Hope you liked the simple explanation of space-time curvature.